Hey, isosceles trapezoids are great. Let's take a look at one and have some fun. So remember, a trapezoid is just any quadrilateral where we have two opposite sides that are parallel to each other. And these sides here, you can see, are bowing out. And to be an isosceles trapezoid, what you want here is to have these two sides actually be equal in length. And by the way, of course, they bow out like this. They've got to bow out like this. This length, you see this is smaller than that length. Now, the question is, given the picture as it's drawn, so this is parallel to that, this side is equal to that side, so this really is an isosceles trapezoid. The question is, and we're told that this is 120 degrees, our mission is to find the angle C. How do we find the angle C? Well, we can use lots of facts about isosceles trapezoids. For example, since these two sides are the parallel sides, we can view this as a transversal. We know these two angles actually have to be supplementary. They have to add up to 180 degrees. If this is already 120 of those degrees, then this must be 60. And since it's an isosceles trapezoid, kind of like isosceles triangles in a way, we know that this angle measure will actually equal this angle measure. These two angles are congruent. And so therefore, if this is 60, bang, I see the answer to the question, what's the measure of angle C? It turns out to be 60 degrees. Lots of structure to an isosceles trapezoid. What property am I using? I'm using the property that an isosceles trapezoid has the feature that the base angles are congruent. The base angles are congruent. And just like a isosceles triangle in a way. So that's why they have a similar name. Okay, hey, let's have some more fun. Is this an isosceles trapezoid? This side's parallel to that side. They're unequal. And notice that this length and this length are equal. And so, in fact, this is an isosceles trapezoid. And we're given lots of information about lengths. We're given that AC, this whole length right here, is 12.7. And BE, this little length right here, is 7.1. The question is to find Ed. Well, that's my name. Find ED. So what's this length right here? So I know this whole length. I know this little piece. I want to find that. Well, one of the great properties about isosceles trapezoid is that the diagonals are going to be congruent. Diagonals are congruent. So, in fact, if you have the knowledge of knowing this length, then, in fact, we can know this length is the same thing. So BD, in fact, is also 12.7. And since I know that this length is given to be 7.1, to find this length, it's pretty easy. It's just a subtraction question. It's 12.7 minus 7.1, and that leaves a mere 5.6 as the length of Ed. Neat! I'll see you soon.